This is section 1.8 in pre-calculus, and this is where we get into kind of the applications of some of the different types of equations. And we'll probably focus mostly on quadratic equations, like those equations that have square terms in them in particular. Okay, so before we get into this specific example, you'll notice that I have an equation written down here, this h of t, and you should probably go ahead and write that down. And then I'll point out what some of these things represent. So it's h of t equals negative 16t squared plus, and then that VO it's actually a subscript of O, and it's not really O, it's a zero. So it's like a subscript of zero, and then t. I call that V naught. Some people would call it V sub zero. And basically that number is going to represent the initial velocity. In other words, the beginning velocity. So like if I throw a ball up in the air, I will throw it up with a certain amount of force or a certain rate of change, a certain speed. That's my initial velocity. And then, of course, as the ball goes up in the air, it's going to be going slower and slower and slower until at a certain instant in time, it's actually going to stop going up, and then it'll start falling. And it may or may not then gain speed as it's falling. Okay, the other thing I would point out to you is at the very end, you have same idea. You have h sub zero, and I call that h naught, and that stands for the initial height, okay, or the beginning height. So if I'm, let's say, if I have like a rocket on the ground and I shoot it off from the ground, the initial height would be zero because it'll be ground zero. If I'm up on the top of a building and I throw a ball into the air, then the initial height is going to be whatever the height of that building is. And then the last thing that we won't change, but I still want to point out why it's that random number of negative 16. So this 16 has to do, it's related to gravity. So it's related to acceleration due to gravity. And in fact, it's half of the acceleration due to gravity. But that number is going to stay the same no matter what if we're talking about a height function. Now, you may have seen something similar to this in physics, and maybe instead of that 16, you might see, I think it's like 4.9. And the reason that in physics, a lot of times they use 4.9 instead of the 16 is because in physics, you're usually talking about meters per second as opposed to feet per second. In calculus, we use the standard units of feet, miles, that kind of thing. Okay, so with that in mind, look at number one. It says Surfside Little League uses a baseball pitching machine to help train players to catch a high fly ball. It throws baseballs straight up with an initial velocity of 36 feet per second. So that's the V sub naught, the initial velocity, from a height of 4.5 feet. So that's going to be my initial position. So that kind of makes sense. So this machine is 4.5 feet above the ground when the ball is released, and it comes out at a speed of 36 feet per second. Find an equation that models the height of the ball after it is thrown. So that's the equation I have up at the top. So I'm going to say the height after t seconds is negative 16t squared. Sixes don't look right. Negative 16t squared plus, they told me the initial velocity was 36, so that's going to be 36t plus the initial height was 4.5. So that's the equation that can model the path of this baseball. Letter B, what is the maximum height the baseball will reach? So just to kind of give you a picture, here's the ground, here's the little machine right here, and from here to here is 4.5, and then the ball is shot up into the air, and at a certain point it's going to stop and start heading back down towards the ground. So they're asking what is the maximum height? So basically they're trying to ask, all right, what is this maximum height off of the ground when it's at its highest point? Well, look at it. It looks like it's following the path of a parabola. Does that make sense based on the equation? Well, I hope so. If it has a t squared, doesn't that mean it has to be a parabola? And if it's a negative out in front, doesn't that mean the parabola is opening down? And wouldn't the maximum height be right there at the vertex of the parabola. So there's different ways you could do this. One thing we could do is we could say, well, this would definitely be a calculator active problem. I could put in that equation, that negative 16x squared plus 36x plus 4.5. And now for my window, I want to think about this. Remember, x is my t, and so that's the time. So I don't need any negative numbers because we don't have negative time. We're not going back in time, right? So my x could start at 0, or the x-axis. And then for the x max, so that's going to be how much time it takes. Well, I don't know. Let's take a guess. How much time will it take, you think, for the ball to shoot up into the air and then back down to the ground? I have no idea. But the good thing about using a calculator is you don't really have to. You try one. If you don't like it, then you try something else. So I don't know. Let's say I think it takes 15 seconds to go up in the ground and then come back down. I definitely think that's way longer than I need, but I'll just say it takes 15 seconds. For my scale, I'm just going to use a 1, let the seconds tick off one at a time. Now remember, the y is my h, that's the height. Well, again, it's going to start at ground level, or it's actually starting at 4.5, but how about if I have my values here start at 0? It's definitely going to start, not going to start below ground. How high do I think the ball is going to go? I have no idea. I mean, it is Little League, so surely it's not going to shoot up to 100 feet or something. I don't know. Why don't we try 50? Maybe we think it's going to go up 50 feet. Now, if we're wrong and the parabola goes off the top of the screen and that tells me it actually went up higher, I'll go back and change that. But don't think you have to get it exactly right the first time. Okay? So let's see what this graph looks like. Well, look at that. I definitely had my numbers way bigger than I needed, but hey, good enough. I can see the parabola. And what are we trying to find? We're trying to find that maximum point. Well, you know how to do that on your calculator. I'm going to say second trace. I want the maximum, so number 4. And this is the situation where you have to give it a left and a right bound. So I'm going to move my cursor. Right now, my cursor is not even on the screen. I'm going to move my cursor. Right now it's over at x equals 5. Come on, thing. I'm going to move my cursor, there we go, to the left of that maximum. That's good enough. Press enter. And then I'm going to move it to the right of that maximum point. Press enter. And then when I press enter one more time, they're telling me that's my maximum point. Now remember, the question here, letter B, was what is the maximum height? That means I want the y value. So the maximum height is that 24.75 feet. So I'm going to say h equals 24.75 feet. That's my maximum height. How many seconds will it take to reach that height? Well, remember, x is seconds. So back to my calculator, the x value at that maximum point was 1.1249. So t equals 1.1249 seconds. Okay. All right, next question. How much time is the ball in the air? So I'm guessing that means from the moment it's released, so from this point right here until it comes all the way back down to the ground, that's my total amount of time. So if I'm thinking of this as kind of like my XY axis, and I'm asking, hey, when is it going to reach the ground? Then I'm trying to find when does the height equal 0, right? When does the height equal 0? So in other words, I want that equation up there, that negative 16t squared plus 36t plus 4.5 to equal 0. Well, I'm solving a quadratic. Again, I might try to solve by factoring. This looks like it's going to be a pain with the decimal. I might try to solve using a quadratic formula. And since I have a calculator, I mean, it's going to be ugly to set it up, but I could use my calculator to do all the computations, and that's certainly fine. But if I have a calculator and I'm looking at the graph, I'm just trying to find the 0 of the function. So let's see. If I want to find that 0, it looks like it's between 2 and 3. So I'm going to say second trace. I want the 0. And again, you have to do a left bound and a right bound. So right now it is definitely to the left of that x-intercept. So I'm going to press enter. Now I'm going to move the cursor. You see it went off the page, but that's because it's down below the x-axis. So that would definitely be to the right of where I'm trying to find. And then I want to take a guess. No, so I just press enter. And so it says the 0 is this ordered pair down here. Now the question said how much time. That means I want the x value. So my answer is going to be 2.368 seconds. But look at the y value. Do you recognize that e? Sometimes the calculator, because of the pixels and depending on the window you have set, sometimes instead of 0, it'll just give you kind of a scientific notation answer. Notice it says e to the negative 12. So basically that means, hey, move your decimal 12 spaces to the left. So really they're saying that the height is 0.0000000, these 11 zeros and then 1. So essentially when you see an e like that, that just means 0. But again, the answer is the x coordinate, so 2.3687. So t equals 2.3687 seconds. Okay. So let's go to the next. So this one is not about the parabola in the air. This is a different question. So as seen in the diagram below, Joe is building a walkway with a width of x to go around the square swimming pool that measures 9 by 9. Okay, so you can tell this inside square represents the swimming pool. I know it seems strange to have a swimming pool that's a square, but hey, it could happen. And then it says that there's this walkway around, and notice all of this, all the way around represents the walkway. I could keep it going. And the width of that walkway is uniform. You notice right here, it's going to be x. No matter where you are and which side of the pool you're on, the width of that walkway is x. Okay? It says if the total area of the pool and the walkway, so the blue and the black part all the way around the outside, if the total area is, what do they say, 361? Okay, if the total area is 361, how wide should the walkway be? Okay, well, let's write an equation based on that phrase they give me. Total area, pool, and walkway. So that's the giant square. Well, how do you find the area of a square? Isn't it just side times side? So I need to think about how long is the side from here all the way over to here? Well, I know that the inside part of the square, I know that this part from here to here is 9. I know that from here to the outside is x, and from here to the outside is x. So does it make sense that the total length of that side is going to be 9 plus 2x? And isn't this side over here going to be exactly the same? 9 plus 2x. And the area of a square, you just do side times side. So the area of this total is going to be 9 plus 2x times itself. And that's supposed to equal 361. So now I have an equation that I can solve. Okay. So what would be the smartest way to solve this? Well, I could square it out, set it equal to 0 and factor, but why don't we just start by taking the square root of both sides and see what happens? So if I take the square root of both sides, on the left, I just have 9 plus 2x. On the right, square root of 361. Again, you can use your calculator, but I think that just comes out to be 19. We can put it in and check if you want to. What is the square root of 361? Square root 361. Well, look at that. It's 19. That was nice that it came out nice and neat. Didn't have to, but glad it did. So I could finish solving. 2x equals 10, x equals 5. So how wide should the walkway be? The walkway should be 5 feet all the way around. Okay? Go to number 3. Your company sells gadget. What's a gadget? I don't know. It's just some random thing, some random product. The amount of profit, Y, made by the company is related to the selling price. Well, that makes sense, right? The amount of money you're going to make off of something has everything to do with how much you sell it for. Okay, so X is how much you sell it for, the selling price. Y is the profit. Using this equation, find out what the price of the gadget should be. So find X. For the company to make maximum profit. Okay, again, I want to maximize Y. Well, I could use my calculator. Let's go a different direction. Look at this. What is this the graph of? Isn't that just a parabola? that opens down. If I were to graph that equation, again, I'm not saying this is an accurate graph, but I know it's a parabola that opens down. I don't know if I have it in the right place, but it's a parabola that opens down. So again, if I want to find the maximum y value, isn't the maximum y value going to be at the vertex of the parabola? So one thing I could do, since I know it's at the vertex, and the question says here, find x at the vertex. I don't need to go straight to finding y, find x at the vertex. So I could go to my calculator and do that like we did last time. But why don't we pull in something that we learned the other day, or that we were reminded of the other day in standard form? Doesn't the parabola have an axis of symmetry at x equals negative b over 2a? And doesn't that axis of symmetry go right through the vertex? So if I can find this x value, then I know where that vertex is. Well, look, this is set up for me. Isn't the b 78? And isn't the a negative 1? So I'm going to say x equals 78 over 2 times negative 1. So let's see, 78 divided by negative 2, isn't that 49? Now, did they tell me if it's dollars? They talk about price, so I'm assuming they mean dollars when they're talking about money. So the items should be sold for $49 in order to make maximum profit. If they had asked me what is the maximum profit, then I would need to plug that back in and actually find the y value. But in this case, they just wanted to know what the gadgets should be sold for. So there is my answer. Now, these are application problems, so it's not like your homework's going to have exact same problems like these. They will have some that are similar, but there are going to be some that you're going to have to think about. So just read the question, see if you can kind of analyze what it's talking about, and maybe see if you can tell if they're talking about a parabola in particular. Okay?